Okay, so if we are given a signal xt, we can find its Fourier transform using this integral. Now what is the inverse relation? If you are given a Fourier transform of a signal, how to find xt? That is called the inverse Fourier transform. Inverse Fourier transform. Remember, in the case of Fourier series, there is if we are given a signal xt, you can find ak using this integral, integration over t naught. That integral is there, xt into e to the power minus j k omega naught t dt. And if you are given the Fourier series coefficients, we can find we can write xt as summation over k omega naught t, isn't it? Okay. So here, in the case of Fourier transform, if you are given xt, given a signal xt, we can find the Fourier transform of the signal using this integral. Now, if you are given a Fourier transform, how to find the corresponding signal xt? Okay, for that, let us go back to the previous expression. We started with the signal xt, and then we considered a periodic extension of the signal t minus k t naught. This is the periodic signal of as a extension of xt, and we are considering. Sorry, there is some problem with this. Okay, then we find the Fourier series coefficients ak, that is 1 by t naught x of j omega Okay, this we derived earlier for finding this x of j omega. Now, if these are the Fourier series coefficients, can we write x tilde t as summation minus infinity to infinity ak e to the power j k omega naught t? Ak are the Fourier series coefficients of x tilde t. So we can write this x tilde t in terms of its Fourier series coefficients. Okay. Now if we substitute this, okay, omega is equal to, if we substitute this here, we will get an expression 1 by t naught summation is that I am substituting the value of this Fourier series coefficients in this expression. Okay. Now what is the relation between t naught and omega naught? Omega naught is 2 pi by t naught, isn't it? So can we write this as 1 by 2 pi into omega naught? I am replacing 1 by t naught with omega naught by 2 pi. Now if we consider this term, x of j k omega naught into e to the power j k omega naught t, can we write this as x of j omega into e to the power j omega t at omega is equal to k omega naught? It is sample versions of that function. This one, x of j omega into e to the power j omega t at omega is equal to k omega naught. Okay. Now, if I am drawing this function like this, let's say it is some function. I am drawing x of j omega into e to the power j omega t. Now, let's say this is that function. It is a function of omega. Now, can you tell me what is the summation? When k is 0, you are taking this value. Is it that? Is this the value corresponding to k0?
Yes, sir.
And when k is 1, what will happen? You are taking a value here. And remember, you are multiplying this with omega naught. Can we say that we are finding the area of these rectangles?
Yes, sir.
Because this is 0, this is omega naught, this is 2 omega naught, like that. You are multiplying with omega naught, and this is the value of that function at a particular value of k. So can we say that we are finding the area of these rectangles and adding? Now tell me what will happen in the limiting case. What is the relation between xt and x tilde t? Xt is what? Limit t naught tends to infinity x tilde t, isn't it? That is the relation between xt and x tilde t. What will happen to the summation then? This is omega naught. If we ask t naught tends to infinity, what will happen to this omega naught? Omega naught tends to,
0.
as t naught tends to infinity, omega naught tends to 0. Then what will happen to the summation?
We will take area of that under that graph.
So can we say that in the limiting case, okay, let me write it here, xt is 1 by 2 pi integral x of e to the power, x of j omega into e to the power j omega t dt. Is this true? In the limiting
Yes.
case, it is the area under this function. Okay. So this is the relation between xt and its Fourier transform. If you are given x of j omega, we can find xt using this integral. What are the limits of this integral? It is from minus infinity to infinity. Okay. So let me summarize that. If you are given a signal xt, we can find the Fourier transform. Its Fourier transform is denoted by x of j omega. It is defined as integral minus infinity to infinity xt e to the power minus j omega t dt. Okay. This is called the Fourier integral. And if you are how to find x of t from x of j omega, we can write x of t is equal to 1 upon 2 pi integral minus infinity to infinity. Oh, sorry, there is a problem here. This integration is with respect to what? Is it with respect to
Omega.
omega?
Yes, sir.
Because this axis is omega, so this integration is with respect to omega. So we can write this as x of j omega sorry, this is minus j omega t. So here x of j omega e to the power j omega t d omega. And this is called the inverse Fourier integral, and this is called the Fourier integral. So this is the relation between xt and x of j omega.